Did you enjoy a little pause? I hope you did, because it's time to take our work to the next level. In this lecture, we'll show you how to go about writing nested loops by using list comprehensions, one of the Python's most distinguishable features. They are a construct that professionals love to use because it relates to working with code that is easy to understand and quick to write. There are several other similar constructs, such as dictionary comprehensions or generator comprehensions, but I would say list comprehensions are the ones that are most frequently used, so we will focus exclusively on them. So let's first study and practice with the construct. We will discuss the applicability of this concept at the end of the lecture. Let's go! To aid us through this lesson, we will create a list called numbers, containing several integers. In the next cell, you can see the code that will create another list by going through the following 3 steps. Create an empty list called new numbers. Specify a for loop where we will iterate over the numbers list. And designate that we want to append the product of each element and the number 2 to the new list. Apart from these 3 steps, we will just print the final output to obtain the desired results. All right. Right here is where we would often prefer to use a list comprehension, since it can provide a concise way to build a new list from the given numbers list. To do this, we must refer to the following syntax, comprising the following 3 main components written within brackets. An output expression for an element in iterable. The output expression is actually a formula or another expression that will lead us to the results we are aiming for. Element corresponds to a member of the iterable. You can also think of it as the loop variable or the iterator variable of the loop we wrote in the previous code cell. Finally, it is clear what iterable means. It is the sequence we are going to iterate over. Applied to our example, this means that we need to write n times 2 for n in numbers within brackets. To improve the legibility of our code, we'll store this expression in a new variable called new numbers before we print the output. Execute, and we can observe that we got an identical output. It is just that this time, we used a lot less code to obtain it. Fantastic! To demonstrate how powerful list comprehension can be, look at the following nested loop where we simply want to sum the values of the elements of the 2 iterables at each step during the iteration. We also want to print the result to make visible the output we're aiming for. Nice! It works just fine. Now we can create a new comprehension that we'll call new list comprehension 1, where we'll store the output of a list comprehension with the relevant output expression, iterator variable, and iterable. However, since we want to refer to a set of 2 nested loops, we can just proceed by writing for the other iterator variable, which is j, and the second iterable, which is range of 5. We see that the output contains the same integers. Please let me point out the fact that it has been stored in a list directly, a feature that will prove extremely useful on multiple occasions in your future work. If we want to, we can double-check the type of the newly obtained list comprehension. Then I'll print its content once more. Apparently, we have worked correctly. Okay, let's elaborate on the construct to illustrate how a list comprehension can be used to produce a multidimensional list. That is, a list containing lists as its elements. We will store the output in a new variable called new list comprehension 2. The only change we'll make to the code defining it will be to add brackets around the output expression and the first iterable. As we execute this cell, we obtain the same elements. The only difference is that this time, they have been grouped into pairs and stored in lists. Just in comparison to what we did with the first newly created list comprehension, we can check the type of the second single element stored in each object to prove that in the first case, we were having integers, and in the second, lists. All right. I would say that we've done a great job so far. However, list comprehensions can provide a large variety of opportunities that can be used on multiple occasions. One very relevant feature of list comprehensions is that they support the option for setting conditionals either on the output or on the iterable, or both. Thus, we can place a conditional on the output to the right of where we've written its expression, or a conditional on the iterable just after we have specified it. Let's examine the following 2 examples that will show us the 2 options applied in practice. First, consider the fact that we will help ourselves with a range function to create a sequence containing all whole numbers between 1 and 10 inclusive. Then assume that our task will be to deliver a list containing integers equal to the values of the generated sequence raised to the power of 3 on the condition that the base values are odd numbers. The latter entails adding the keyword if before the closing bracket, and then a condition that the loop variable should not return 0 as a remainder when divided by 2. As we execute the cell, we can see that only the numbers 1, 3, 5, 7, and 9 have been raised to the power of 3. They have also been stored in a list. Just for comparison, here is the non-Pythonic alternative of a nested loop with which we can obtain an identical output. You see? Nice! And how can we set a condition directly on the output? To keep things simple, we can move the same condition from the end of the list comprehension to right after the output expression. As we execute this code, we get an error message though. Why? The reason is that we must provide a clear indication to Python about what exactly we want to be displayed in each potential outcome. In other words, we must remember to always suggest an output value for the cases in which no execution of the output expression will take place. In this particular example, I can just add else even here to indicate that we have no numeric value obtained in case the base value was an even number. Execute and great! Now the results are complete. To sum up what we said so far about using conditionals and list comprehensions, remember that you can place a conditional on the right of the iterable to filter out certain values from the iterable that you don't want to go to the final calculations at all. Alternatively, you can set a condition on the output, in which case you will practically alter the output obtained for certain elements. Great! In this lecture, you saw that Python's list comprehensions focus on what you want to obtain from a given list by using an intuitive and elegant syntax. However, it is good to remember that although Python community loves this tool in general, there are certain situations where you might want to opt for some alternatives. Here are several notes that will be good for you to keep in mind as you move on. List comprehensions are a very powerful tool because it can be applied to a very wide range of cases and can deliver many types of output. List comprehensions are a fantastic example of high-quality code. They make writing Python a lot more intuitive and resemble spoken English to a great extent. And that's what the initial idea behind Python is. Don't forget that, while programming, you will always be faced with the trade-off between writing efficient code versus code that will perform better in terms of speed and precision of delivery. On average, list comprehensions require more memory and run more slowly. Therefore, while aiming to optimize your code, given these two constraints, in some situations, you might be better off choosing among other alternatives, such as nested loops. This was quite a lengthy lecture, right? However, it was also crucial because we covered a topic that is essential for the skill set of every programmer who wants to write advanced Python code with ease. We hope you enjoyed it. Thank you for watching.